Having vacuumed up some of the foam to clean the piece up, I brought it back up to the layout, put it back in its alignment that I had previously marked. You can see the red lines there that it butted up against. And I've gone ahead and marked some black lines on either side that is around where the hole is. And then what I did from that point is put the long bit down through it and just touch the plywood so I knew where the center of that cavity is. Because I don't want both leads going through the same hole. I want to put a hole slightly spaced so that I don't have to worry about either of them grounding out on each other. So that's what I'll do off camera, is just clean up that hole that I made a little bit and drill 2 other holes through. I'm not going to bore you by soldering leads together and stuff like that, but I'll show you the finished product. I solder my leads to the bottom of my rail joiners. It's just where I found it works. If I really have to, I can go back and solder the rail joiners onto the rails. I haven't had the need for it in any of the past layouts I've built, so I'm sticking to that. I find in N scale the ties are so close together that soldering, in this case, this joint here is where the leads will come up between the 2 rails of this bit of track. So I find I don't have a problem with that, the rail joiner feeding the track the voltage. So I'm sticking to what I do. If you have a more preferred way that you want to do it, I'm just showing you what works for me, and adapt it however you find it will work for you. That's the whole point of the hobby. We take an idea and run with it to make it our own, to make it work best for us on our layout. There's no firm way of this is the only way you can do it. That's definitely not what I'm trying to convey in this video. So we'll be back with a moment with the prepared leads, and then we'll try and get this section of track all put together, and then it'll just kind of be a rinse and repeat for all the other ones, apart from me showing you the hot knife for doing a couple of the other pockets. Now I did go back and deepen that up to 1 inch. When I took a look at it, the 3/4 I was thinking that may have been a little tight, so I did make it 1 inch deep. Now the downside of using a router to make those cavities in the bottom of the risers is you end up with little bits of very staticky foam all over everything. The downside of the hot knife is you're going to have the vapors from melting the styrofoam. So you just have to choose what you want to put up with, because there's negatives to both ways of doing it. Or you can get out a carving knife or your X-Actos and just go at it and chip pieces out. That's would be the harder and messier way of doing it, as far as getting a clean cavity when you're done. So back in a moment. Okay, so we're back with the riser, and what I've done so far is taken some 22 gauge wire that I use as my feeder lines from the bus line, and I've chopped off a red and a black about 8 inches long, stripped just right around 1/2 inch off each side, and gotten 2 more pieces at roughly about 6 inches, and attached the magnet to the end. So what I'm going to end up doing is soldering at the end of the 2 magnets, so that I've ensuring I've got good electrical contact with the one end, I'm going to, on the other piece of wire, solder on some rail joiners to replace these two here on this track, which coincide with the center where the hole's been drilled. And that will give me about an inch or so, because these are, the riser is 6 inches. I've cut these at 8. I'm losing, say, an inch with the soldering activities. So that'll give me an inch extra that I can actually have it tilted to the side to make sure that when the magnets join up, that they will appropriately connect to the right feeder line. And what I will do and show is I'm going to take some heat shrink tape on the black one and have that actually come up over the top magnet, but shrunken just where it joins at the wire, so that that top magnet, I can pull it out or feed it back down the tube to connect it, and then I'll just leave the red one bare. Though once all the soldering's done, I will take a marker and mark both ends of the red one. The marker will essentially provide a thin insulation cover, but it's more just to ID it outright. And when I drill the holes in the plywood, I will drill them this way. So if this is the plywood and that is the center mark that I've made in the plywood, I'm going to drill them this way so that they actually are on either side within that pocket, and then any excess wire will just, which will only be about an inch, will loop up into the pocket that I've cut out using the router. And I believe that was about 1.25 inch pocket, I believe, that I had drilled out there, which you've already seen in a previous or earlier in this video as I'm chaining all these small videos together. So I will be back with you as soon as I've soldered the rail joiners up, and then we can take a look at alignment and such that will be needed to get the rail secured to this riser. So back in a moment. Okay, a tip about soldering around magnets. I was hoping this was not going to happen, but it did. So I'll show you what's going on. Okay, take this black one. Now, I have a unsoldered magnet, and you can see, even though it's grabbing, it's not. I'm able to pull it away. Now I've got two magnets here, and I can barely open them up. They're so strong together. Now, let me pull this one off and take the opposite one, and you can see how it's barely holding on. Well, that's because of, even though I was very careful and didn't have very much heat on it for very long, just heating up the wire on the end, so very close to the end of the magnet, demagnetized it, or at least greatly decreased the magnetism associated. So, luckily, I've got an option or two. One is I've got enough wire that I can just cut that off and do the same thing here. Cut that off, call it a loss. What I will need to do is strip back the wire sufficiently so that I can get the eyelet through and wrap the wire farther up and actually solder farther down the wire. And what I can also do is take a paper towel or a Kleenex, toilet paper even, wet it with cold water and wrap that around the magnet to keep it cold while I solder farther up. So definitely, if you want to try this, try and avoid getting any heat on the magnet at all, because, as I said, I was very careful because I knew this could occur, and it still occurred, that any heat being transferred into the magnet will impact its magnetism. So we'll be back in a moment when I've got this all sorted out. Back in a bit. Okay, red wire has been soldered. Let me just try and steady the cam so you can see. So what I did, I stripped about almost an inch back and then slipped it through the eyelet, folded it back over and had it so that it was laying up tight. Used a piece of wet toilet paper, wrapped it around the base so that just the 1/4 inch at the top was sticking out, soldered that together, made sure that everything was nice and quenched, and then did the same thing on the bottom end, and then just crimped with the pliers the unsoldered wire so that it's tight. I'll go back and paint this with a liquid, I can't remember what this stuff's called now. Connector coating is the proper name for it, but it's liquid electrical tape from what I usually call it. And I'll put on a shrink wrap bit on this exposed piece. Even though it's going to be down through the plywood, I'm still going to shrink wrap it just to make sure that it's held tight. Now, as you can see, that's quite a lot different with no heat being applied to the magnets as compared to what I showed in the previous clip. So that's what I shall do for the black wire, and then we'll be back with the next little bit. Back in a moment. Okay, we're back with all the soldering complete and the liquid electrical tape placed on the red leads. Now, I did look around and I managed to find some shrink tubing, which I've already shrunk the one end down to make a boot to go over that so that nothing can short out internally. And I've got my multimeter, and the one lead is clipped to the rail with the red lead. So let's check for continuity, and we've got continuity. So I'll flip that over to the black, and we'll change down to the black, and we've got continuity. So that is all good. We've got good strong, if I can get that to let go, we've got good strong electrical connection between both leads through the magnet, and the magnet is nice and strong and latching very easily. So what I'll end up doing is slipping that up so that it will cover that, tuck that in, and then let's run over here, and there was the center point. Sorry, it's got a little covered over there, in the middle one there was the center point when it was drilled and everything was in place. And then I'll put the red lead down that side and the black down that side so that they're well spaced out, but still within that cavity. And there could be no contact between the leads within the cavity to cause a short. And then we'll get this piece in place and get the leads set up. So then we still have to deal with running a lead on this line and a lead up here, as this piece is all secured together. So I'm not too worried about that. So what I'm going to do is drill a hole through this part right here and this track right here, and where they join together I'll just make a larger cavity, join those two leads together to the magnet, and then that'll go through the same as the other place. So that is about it. I will, when I dig the cavity out for the next, for the positions over here, sorry about my voice, I'm going to use and demonstrate using the Tippy foam wire cutter. And this is similar, except it uses a very smaller Canthal wire, or whatever the wire is. I'm blanking on the name at the moment, but it is a uniform length, but you can bend it into different shapes. And this one's showing the oval, this one's showing a more squared one. And you can barely see it through here. This one's showing a very narrow, deep one. So, but they're all the same actual length of wire if you straighten them out to keep the resistance consistent between the 2 points. So, when we come back, I'll be showing you how the Tippy works. So, back in a moment. Okay, we're back. So here's a look at that piece that we just worked on, or I just worked on. I got to stop saying the royal we and take possession that I worked on. As you can see, the track is a little springy at that point, but that's because if we take a peek underneath, you can see that those sections are punched through the holes, and it's just the springiness of the wire. But once that is adhered down, the wire will just collapse into the cavity and there'll be no issues. So that's that piece done. Now the long piece that wedges into that slot right there, I have actually moved down from where I was considering in the previous clip, and I've actually drilled 2 holes here, and I will show you the corresponding what's going on here, so that those 2 holes are centered on either side of this hole. And what we'll use the hot wire cutter with is, in the bottom of this, we'll build a channel between these 2 at the bottom, and then a cavity under this section here. So we'll be back in a moment and we will continue with that. And we're back. So what I've got is the Tippy hot wire foam cutter. Now it does come with the wire head that's shown there, and these are all pre-formed, a more rounded one, a narrower one, and a very, I guess, extremely narrow one for punching more holes. And at the time that I bought mine, it actually came with 2 extra straight ones that you could bend in any form that you wanted, any shape you wanted, I should say. So if one of the ones that were present weren't useful for you. Now at the lower bend, that's just around 1.125 inches. So I'm going to definitely be plunging up to the first bend, and it's got a power pack, and it's just a press on button, and that heats the wire up, and then you just jam it in and do what you need to do. So for what I need to do, I've got the hole which kind of skewed off on me when over here when I was hand pushing that drill bit down to generate the hole. And I've got another hole over here, and this is where the main cavity is going to be. I'll just do a lighter hole or channel from here, and I'm just going to hot wire the lead wires down in here. They'll meet up with the other wires and the magnet bit in here. So let's get going. So just press it to turn it on. I've got a little bit of fuzz from a previous melt going on, and I can start smelling it already. And this will be definitely a lot less foam fibrous than what had happened using the rotor, but it is going to stink, and that's the real only downside. So following my line, I'm going to plunge it down in, and run it over to there, and come back out. Now that's the other thing, it's stringy, but it's nice that as soon as you push the off button, it shuts off and cools down. So there's our plug that extracted, and that's definitely going to be well deep enough, though I am going to tidy up the side of the hole a little bit, since this isn't a full inch wide. It's let's see, 1, 8, 2, 8, 3, 4, 5, 6, about 7/8 inch the bend on this one, and I wanted a full inch, so I'm just going to go ahead and get the rest of that out. There, some foam fibers that will have to be collected up. Now I could switch to one of the other tips, such as this tip, or even the narrower one to melt in my channel, but I don't need it horrendously deep. But you know what? Let's go ahead so I can show you how to do the tip. It's not hot. It does cool down very quickly, and changing the tips is extremely easy. You just have to make sure you get the tips in the hole. And again, the resistance of that length of wire is the same for all these pre-bent tips, just as it is for the provided for, and it's just a pinch in, and we got that changed, and it's just a matter of pressing the on button to let the resistance of the wire heat it up just like a filament, as we mentioned before. Let this one start stinking a little bit, and then come in and through. And again, as soon as I let it off, and we're back with a fully charged battery now. Sorry about that. Things happen. At least most of the footage was salvageable. Okay, so what we're looking at is the wiring ready to be buttoned up and have this put back on the layout. So what I did was I first soldered the rail joiners after making sure that they fit a piece of test track onto the wire leads, and then just arranged them so that the black is to the black and the red is to the red, so that they're properly oriented when the track is going to be installed. So I'm not trying to twist the wires inside the hole in the foam, and that way, by taping it down, I'm putting them predominantly where they need to be as far as having the appropriate amount of tension on the wire. So then it's just the two leads, and maybe the red will show up a little better. So the two leads coming in, and then the short lead with the magnet soldered onto it, and same technique as before. Wrapped the magnet ball up with wet toilet paper, and then just soldered the tip of the 1/4 inch of wire loop back onto itself. And then I've now coated that wire with the connector coating, or liquid electrical tape, and it's MG Chemicals is what's available here in Ontario, Canada. So, and those in Ontario, Sayle, S-A-Y-L-E. There's electronics. That's where I get my wire and such from, and they're in Cambridge and in Burlington are the closest ones here in Southern Ontario. And of course they're in Mississauga as well, but S-A-Y-A-L. Pardon me, S-A-Y-A-L. So, soldered the 3 lines together, and then just put some shrink tubing on the on that joint, so that that's no contact can happen when everything's folded back in. So it's I just used a nailed cable, I don't even know what they're called, thing in, just to put tension and keep the lines here firmly seated. And that way, if I have to pull and tug, that the line is still moving. I'd initially thought of hot gluing it in, but that makes it immovable, and if you just need a 1/16 of an inch more, you're out of luck. So I put something in that is allows the wire to have a little bit of movement in case I need to pull some slack back. So these are essentially ready to go. It's just a matter of slipping the boot all the way up to cover everything. Now I didn't bother with putting the liquid electrical tape on the lower ones because they're going through their individual holes. So I'm not too concerned about a short because they're going to be spaced, you know, 1/2 inch, 3/4 of an inch apart. So no concern there. As you can see, I've stripped a little bit of the ends of the wire, and I've checked continuity from each of these wire tips to the corresponding rail joiners at the top before I put the liquid electrical tape down and did the shrink tubing on the joints. So from here it will be sticking this back on the layout. So I don't think I'm going to continue this series further. It's pretty much a rinse and repeat for all the other risers, and so I'll sign this series off for now, and the next series, or the next video at a minimum, hopefully I can keep the time down, will be actually securing the track down using the construction adhesive to the top of the risers. So I've got my cup of tea ready to go. I've got Rush queued up on the stereo to listen to and get some Clockwork Angels live going, and spend some time trying to make some progress on the layout. So it's Dave signing off, and hopefully you have a chance over this weekend to get down and run some trains, or to make some progress on your own layout. Talk to you on the next video. Bye for now.